In chronic retrograde tracing, endpoint interpretability often carries more weight than early fluorescence intensity. A tracer may label neurons clearly, soon after application, then move through a long survival interval, perfusion, fixation, sectioning, storage, and imaging before the data are interpreted. Fast blue is often used in retrograde tracing studies where labeled neurons need to remain identifiable after extended survival periods. The relevant readout is the quality of the signal after the tissue has gone through the full experimental process. For studies involving regeneration, chronic injury, or long-term changes in connectivity, the biological question develops over time. The tracer must remain detectable across that timeline while preserving enough contrast from background signal to support interpretation. Injection site behavior also plays a role. In compact anatomical regions, local spread into adjacent structures can change how projection patterns are interpreted. Injection volume, placement accuracy, tissue disruption, and the local tissue environment can all influence labeling specificity. Several other variables may shape the final readout, such as the survival interval, tissue handling, fixation conditions, section thickness, storage conditions, imaging setup, and whether the study includes additional staining or labeling. Fast blue can be useful when long-term fluorescence retention is a central constraint. Comparative tracer studies have reported persistent fast blue labeling across extended survival intervals, which is one reason it continues to appear in chronic tracing workflows. Researchers may select other retrograde tracers when the experiment depends on specific color channels, multiplex labeling, immunostaining compatibility, or a different detection method. Tracer selection works best when it starts from the endpoint. The tissue condition, the imaging method, the anatomical region, and the level of signal clarity needed to answer the biological question. Polysciences' article on fast blue and fluorescent retrograde tracers looks at these selection factors in more detail. Use the link in the description to read the full article.